Both the idea and the results of some type of redundancy for that default gateway is a good idea. I mean, I love first hop redundancy protocols, but there's more than just one to choose from. In the previous video, we took a look at Cisco's proprietary HSRP, Hot Standby Router Protocol. And in this video, I'd like to take a look at both how to implement and verify VRRP, Virtual Router Redundancy Protocol, which is an open standard, and the syntax and the commands are very similar to HSRP. Let's take a look. So for our game plan, we use the same topology, except we're not going to be doing HSRP, so I'll go ahead and erase that. Instead, we'll use the exact same topology, same IP addresses, except this time it'll be VRRP, the Virtual Router Redundancy Protocol. So here's our plan of attack. I've reset the lab so that we're not running any first hop redundancy protocol at the moment. And what we'll do is we'll go into interface 1/0 on R1 and 2/0 on R2 on this common network segment, which is supporting the 10.16.0 network. And we're going to create a virtual IP address at .3 using VRRP. And then we'll tell the PC that instead of using the default gateway of .1 or instead of using the default gateway of .2, use .3. And that way these two routers can support it. And with VRRP, they don't use the terms of active and standby. They have a couple other terms which I will show you in the interface to represent who's in control and who's sitting back waiting for the primary device to fail. So without further ado, we'll use the same topology. We'll go to the lab and I'll walk you through step by step implementing and verifying VRRP in this network. So we are logged on to our administration PC, which is DCNUG. We're going to open up PuTTY up in the upper left-hand corner. And then we're going to click on servers and open up connections to R1 and also to R2. And let's begin in R1 just to verify what interfaces we have. Show IP interface brief, just to make sure we get the right interface. We're going to be configuring VRRP on this interface right here on R1. So we'll go into configuration mode, interface gig 1/0. Now in HSRP, the command was standby. With VRRP, it is VRRP space. We're then going to specify a group number. Let's use 10 again, space, and then a question mark, and then the keyword IP, space, and then the virtual IP address that we want to use, which is 10.16.0.3. Press enter, and bada bing, bada boom, it is done. And this is just stated that its state is master. So in HSRP, they use the term active. Here on the primary device with VRRP, it uses the term master. Next, let's go configure R2. So over at R2, we'll do a show IP interface brief to confirm which interface we're going to configure. And that's going to be this guy on the 10.16.0 network. Fantastic. So we'll go into configuration mode, interface gig 2/0, type in VRRP space, question mark. We'll specify our group, space, the keyword IP, space, and then we'll put in our virtual IP address of 10.16.0.3. All right, I had to think about that for a moment. Press enter. And it is going through its changes as well. So if we want to see the details of this, oh look, it just became the master. Check that out. So if we do a show VRRP and press enter, so this gives us a good opportunity to chat about some of the differences between the defaults with HSRP from the previous video and VRRP. With HSRP, they use the concept of active, and in VRRP, they use the concept of master. They both use the concept of a virtual IP address. They both have behind that IP address a unique MAC address. They don't use the same one, but it's a unique address for that IP address. There's an option called preemption. Now in HSRP, that is disabled by default. It's enabled by default with VRRP. And basically preemption says, if I have the stuff that should make me the master and in charge, I'm going to go ahead and take over. Even if there's another current master in place, I'll let them know. And with VRRP, the concept is the highest priority wins. Now both router 1 and router 2 have the same priority. And if they both have the same priority, the device on that network segment with the higher IP address becomes the master. And that's why R2 took over, because preemption was enabled and it had a slightly higher IP address. It had .2 on its local interface instead of .1, which R1 had. So if we take a look at R1, and over here at R1, if we type in end and do a show VRRP and press enter, here's its role. It's acting as the backup as opposed to standby. Same logic, but different words. It's also stating here that the master router is at 10.16.0.2. So now what we would do is go back to our client on that 10.16 network and specify that for the default gateway, it should point to 10.16.0.3. And then it has two good friends here, R1 and R2, using VRRP to help support that IP address. so that if one of them fails, hopefully the other will be there and can pick it up. So what I thought would be a good test of this too is let's do this. Let's go configure the client with the correct default gateway, and then we'll come back and we'll disable one of the interfaces and see the other one pick up. So here on this Windows 10 client PC, in the bottom left-hand corner on this flavor of Windows, you can right-click, and then from the menu, we can select Network Connections. And from here, we can right-click on the Network 1016, and from the drop-down, select Properties. And then from here, we can double-click on Internet Protocol version 4, and then change the default gateway to be .3. And we'll click on OK. Then we'll click on OK again, and then we'll go verify that took. So go ahead and bring up a command prompt in any way you want to. And at the command prompt, let's do an IP config on this Windows machine just to verify that we have a default gateway of 10.16.03. Next, let's go into a ping to, so for this lab, let's ping this 192.168.1.11, press enter, and we get a response. So the default gateway is .3, the virtual address, and the 192.168.1.11 is an IP address on the other side, the right-hand side of router 1 and router 2. Super. So let's go back to DCNUG, our management PC, and let's take this interface gig 2/0 and bring it down. So we'll go into configuration mode, interface gig 2/0 here on R2. We'll do a shutdown, and there's going to be some messages going back and forth regarding VRRP. Fantastic. And if we go take a peek over at R1, we should have a console message indicating that it is now the master. So we still have support for that virtual IP address. So we do a show VRRP again. The state on R1 is now master. And if we go back to our client, who hasn't changed, it's just sitting here, if we do that same ping again, we still have a response. It still works because we still have a router that's acting as the master router for that virtual IP address of 10.16.0.3, which is this client's default gateway. So in this video and lab, we've taken a look at another FHRP, First Hop Redundancy Protocol, specifically VRRP, the Virtual Router Redundancy Protocol. I hope this has been informative for you, and I'd like to thank you for viewing.